AppFabric caching, how to use it, when to use it, and also a little bit about the differences between what's on-premise and in the cloud. So as I said, it's a 300-level session. What I'm going to do at the beginning is I'm going to talk a little bit about this concept of caching, in particular around the idea of distributed caching versus any other sort of caching. We'll talk about what is AppFabric Cache. I'll do some demos, and then we'll talk a little bit about the difference between the on-premise version of AppFabric Cache and the Azure version or cloud version of AppFabric Cache, both of which are in production. Right? You can get both the on-premise and the cloud version of the cache today. So why are we here to talk about caching? Well, this is a picture of a typical web architecture. Right? We have users. They're the little blue people in the top. They're calling out through their browser to our web servers. Our web servers are running some sort of software that's generating HTML responses that are going back to the users in their browsers, and the users are, fairly happy. Our web servers are talking to database servers. Our database servers, in a typical web architecture, we might have two. One's our primary and one's our sort of hot backup. And there are a couple of issues that you have to tackle when you start talking about this kind of architecture. You notice in the middle, we don't just have one web server, we have multiple web servers. So every time a user comes to one of our web servers, we have to make a round trip to the database for data. Every time the database gets a database query, it has to go to disk potentially. It has to use CPU for sure. On every request, even if nothing has changed since the last time the user requested a page or requested data, we have a lot of repetitive things going on. Okay? The biggest thing that happens in terms of this architecture is when you want to try to scale it. Scaling the front end is fairly easy, right? Scaling out to more web servers over time is, once you have your web server, once you have your code written in such a way that it can scale to multiple machines, adding a new machine, not a big deal. Adding another database server or partitioning your data in such a way that you can continue to scale is actually a very hard problem even today. Right? Certainly there are tools and ways to do that, but database scaling is still not at least as easy as web scaling. Whoops. One other problem is, as I said, a typical cache, let's say in ASP.NET, is to use the ASP.NET HTTP cache, which is a great, fine in-memory cache. In-memory, that is, the cache is in memory inside of your web server along with your web application. The issue with that becomes, if you start using the HTTP cache, and pardon me, my shoe came untied, and if I don't tie it, I'll probably trip and fall, so let's fix that now. If I'm using the ASP.NET cache, it's great, but there are some problems that can arise once you're in a web farm scenario there. Like, for example, if you're caching data from your database in your web tier with the HTTP cache, and my favorite scenario is, the CEO of your company is looking at a financial report. The CEO goes to web server 1, they look at the report, everything looks good. They go to the meeting, they refresh their browser, they get a different report, and that report doesn't look good, right? That's actually why most executives insist on the export to Excel feature, right? Because, of course, they can export it to Excel and they can do anything they want with it in Excel, right? Sort of the Enron kind of a thing, right? But if they're actually going to the web server, you could have a case where each web server's cache in memory is out of sync with each other, and one web server might have an old version of the data that is bad or doesn't look so good for the company. Another web server has a good version of that data. Which server that CEO goes to is going to depend on how you're doing load balancing. If you're doing HTTP sessions, you might be doing sticky sessions, in which case Then you're making people stick to one particular server. So there's all sorts of issues with in-memory caching inside of your web tier in this architecture. So the main three problems on this slide are, if we're using session, we're probably going to have to use sticky session, sticky load balancing. If we're using in-memory cache inside of our web tier, we have the potential for our data to have a cache coherency problem across all of our web nodes. And our database is likely to get saturated, either CPU or disk. And of course, if our CPU is saturated, we can upgrade our server, and if our disk is saturated, we can get faster disks. But that only gets you so far, right, in terms of scaling out your application. So those are the problems. So how do we scale this? How do we scale this kind of architecture? And this has actually been pretty much figured out for now. Companies like Amazon, Facebook, Twitter, well, maybe not Twitter, right? Because if you go to Twitter, you notice that they have their fail whale up quite often. So Twitter may have not completely figured it out. But Facebook, Amazon, the large web sites handle millions of hits a day, millions of users, and they do that fairly seamlessly. And one of the ways that they do that is that they cache things like crazy. Now, there's all sorts of caching. The caching we're talking about in this particular session is back-end caching. That is, caching that's controlled by your code. There's also, of course, HTTP caching, which you can control with different HTTP headers, which those companies use as well. But again, one of the things that these companies have figured out in terms of the architecture that really, really scales is even if they have databases on the back end, which both of those companies do to some extent or another, even though there's the whole NoSQL movement as well, they cache data like crazy, right? And they don't cache that data in their web tier. They have a whole separate tier, right? They have a whole separate tier that caches, okay? So this is basically how we're going to solve the problem of scaling that architecture is by using something called distributed caching, right? Distributed caching allows us to treat multiple servers as if those multiple servers are a single server. Or better yet, even, I like to think about it as all of those servers in my distributed cache cluster, however many there are, they're really just a chunk of memory to me, right? They are, essentially RAM. And, instead of addressing the RAM through my API on my local machine, I'm addressing that RAM through a network call, which does have some latency associated with it. So you might think, well, how can you make, your web application faster if you're, adding essentially an extra hop to get data to your web tier? And the answer is we're talking about scalability here. We're not necessarily talking about raw speed. Or I'm not sure I actually was talking there at all, so let's say that again. We're not necessarily talking about raw speed of an individual request. What we're trying to do is make sure that whatever speed our requests are, we can maintain that speed and that performance as we scale to thousands and tens of thousands and hundreds of thousands and potentially millions of users, right? Now, most of you might say, oh, well, maybe it's time for me to get up and go to another session because I'm not building the next Facebook. So, why do I care? Those are, the big examples of this architecture. But as is the case with every architecture that sort of the big companies, that need a particular architecture, they're the ones that sort of figure it out, and then it sort of trickles down to, us normal people, right, that are building normal applications. And you can take advantage of this caching capability and allow your applications to scale without necessarily having to add extra web servers or upgrading your database server. The idea is to take commodity hardware. Obviously, you want as much RAM as possible. Take that hardware and put it together and essentially create this distributed caching tier. Okay? Now, when we're doing caching, we have to be concerned with a couple of other things. Expiration, right? When an object becomes stale, how long are we going to let these objects stay in the cache? At what point do they get flushed because they're stale? And what happens if we oversaturate the cache? What happens if we use up all that RAM, right? If we use up all the RAM on a Windows machine that's running .NET, right? .NET runs a garbage collector. So the garbage collector in this case is something called eviction. These are just a couple of terms that I want to get the definition down of at the beginning here, so as we go along, we all have a common vernacular. So AppFabric cache. AppFabric cache is a distributed cache. It's a distributed cache where the cache service runs on multiple nodes. Okay? If you're using the on-premise version of the AppFabric cache, you decide how many nodes that is, and you install AppFabric cache on some number of nodes and configure AppFabric cache to be a cache cluster for your application. If you're using the Azure cache, and I'm not going to differentiate this on every single slide, but the basic difference is going to be just like in the case of Windows Azure, whereas you can build your own Windows machines or even virtual machines on your own network and run your web apps there, or you can take your web apps and take them up to Azure and say, hey, would you do this for me? So the similar idea here is instead of having to have a local infrastructure, I can go to Azure and say, hey, create me a distributed cache, and it just takes care of it all behind the scenes, so we don't really have to deal with the management. So that's the big delta between AppFabric cache on-premise and in the cloud. On-premise, of course, we still have to manage those servers and install software and make sure that they're kept up. And in the cloud, all we have to do is say, hey, create us a cache. This is the size of the cache that I like to have, and go. Now, just to be clear, and I will say this again because it's important, if you're building an internal application, that is, if you're building an application that's running on servers on your network, AppFabric cache is not the cache for you, right? Remember I said one of the downsides of caching is we're essentially putting stuff up on a different tier, and we're going to have network latency. Well, the network latency from running applications in your local, on-premise environment and then connecting to the cache in the cloud means you're not going to get very much out of that, right, because of the network latency. On the other hand, if you're building a Windows Azure application, right, a web role or a worker role or a VM role, whatever, well, then the Azure cache can be in the same data center as your application. Then you are going to get, a very sort of large bang for your buck in terms of the performance and scalability. I should say scalability and performance. Because we're really talking about scalability for the most part when we're talking about distributed caching. Okay? Other than that, and there's a couple other differences that we'll clear up at the end, pretty much everything I say will apply to the on-premise version or the cloud version. AppFabric cache is has a .NET API, right? It's written in .NET code. I can store any object in it, okay? I can store any .NET serializable object. I can store XML. I can store binary data. I get to choose what to put in the cache. In this particular version, AppFabric cache is optimized for a particular caching pattern called the cache aside pattern. Cache aside pattern means the way you're going to use the cache is going to follow a certain pattern of code. And the pattern of that code will be, you'll look to see if the object you're interested in is in the cache. You'll go to the cache and say, hey, cache, do you have object A? And if the cache says, yes, here's object A, hands it to you, you use object A, and you go on your merry, happy way. If object A is not in the cache, then you respond in your code by going and getting object A. And again, that could be data from your database, could be data from a web service call, it could be data that you pulled from the file system, from the registry, doesn't matter, right? It doesn't matter where the data comes from. You're going to take that data, make sure it's wrapped up in an object that can be serialized, so one of these three object types, and then you're going to give it to the cache and say, label this as object A. Let's say that's the first request that hits your web server. Well, then the second request, the third request, the fourth request, until object A is either expired or expelled, although, again, expiration is much more likely. Your code will continue to get that data from the cache, and then you'll avoid having to go get that data. Okay? Now you might say, well, how is that going to really make my application scale? The way that it makes your application scale is, as I said, in that typical three-tier architecture, the tier that ends up getting to be the most difficult to scale is the database tier. Basically, what a distributed caching tier does is it takes the load off that database. So things that you normally would go to the database for, like what we would call reference data, right? A list of cities and states or countries, zip codes, regions, sort of lookup data, right? Those are classic examples of data that in an application, it generally makes sense to store in the database because they change sometimes. Sometimes you have to go in and, add a zip code or add an area code or add a country, not very often. But it doesn't change often enough that you can't cache it for a long period of time and avoid having to go get that data from the database. That's the typical kind of data that you would keep inside of a web tier in sort of an in-memory cache as well. And the distributed cache can make that same functionality, but make that same data, the same data that one web server sees is the exact same data that all of the web servers see, right? Because the distributed cache acts like, a big hunk of memory, not only to web server 1, but to web server n, right? No matter how many n is, if all of our web servers are going to the same cache, they're all looking at the same data, and then we can get away from some of those staleness issues that we talked about, okay? So the idea of a distributed cache is not necessarily to improve the performance of a particular page, but to be able to take the stress of going to your database for every request or many requests and taking that load off the database, which of course you can do with in-memory caching as well. But the fact that now we have this idea of a distributed cache means we don't have to worry about cache coherency when we're keeping things in that distributed cache, right? We have one version of the data. All of our web servers are using that same data, or application servers, right? It doesn't have to be a web server. It could be a WCF service or whatever, right? All of them are going to be using the same copy of the data. Okay? That makes sense? Okay, so the cache-aside pattern just means we're always going to program defensively. We're always going to look to see, is the object in the cache? If the object's not in the cache, we're going to go get the object, we're going to use it, and we're going to put it in the cache. So the next request, the next thread, the next service call, the next request for a web page, will get to use the version that's in the cache, right? And that's typically the way you program against the HTTP cache as well. You always want to be defensive against what if the object isn't in the cache, right? If the object isn't in the cache, you have to be able to respond. And that's the cache-aside pattern. There are other cache patterns, like write-through caches, where if you change the object in the cache knows where the object is stored in your database, and it will go change the data in the database. This version of AppFabric cache doesn't have that capability, right? It's not a write-through cache. You can change object in the cache, but that won't change the back-end data of where the object in the cache came from, right? It's going to be two separate copies, and you're going to be responsible for keeping them in sync if you need to keep them in sync. Oh, turn that around. Forward, forward. So the idea is, in between our database tier and our web tier, we're going to insert this caching tier. The caching tier is going to be made up of 1 to n machines, again, depending on our needs. In the case of on-premise, right, we're going to be managing those servers. We're going to be installing AppFabric on those servers, and we're going to make sure that they're all part of the same cluster. In terms of Azure, the diagram looks exactly the same, except we don't control that box, right? We don't control the servers or anything like that. We just essentially ask for a cache to be created for us. So this can help us solve a couple of those problems that we saw in the earlier diagram. First of all, the biggest thing we solve is taking the load off the database. Now the database can be used for things that the database is really good at, which is transactions, right? Taking in orders. And you don't have to worry about your database getting overloaded by queries for data. You can use it for, again, the really important stuff. The less important stuff, or the stuff that not necessarily it's less important, but we want to take the load off the database, we're going to store in the distributed caching tier. And the other thing it helps us to solve is the sticky session problem, because if we have one unified view of the cache, even though it's on a separate tier, right, it doesn't matter what web server we route the user to, because the user is going to see the same data. Okay? So that's going to help us to avoid having to use the sticky sessions, which generally helps us to scale. Okay? So the AppFabric cache is a Windows service. It runs on some number of machines. You decide how many machines. Obviously, the more memory you can give those machines, the better. But again, when you think about your application architecture, typically the expensive machines are down at the bottom, right? If you're trying to figure out, what web servers are we going to use and what database servers are we going to use. Web servers, like I said, it's pretty easy to add a new server. So you typically don't really worry about the hardware on those as much. But on the database server, right, you want to make sure that you have really good hardware. You want to make sure that you have really good disks, fast disks. You want to make sure that you've got backup plans and disaster recovery plans in place, because if something goes wrong in the database and you need to recreate it, well, that's pretty important, right? Very important, always. The caching tier, all we really care about is memory, right? So the idea is we can take, some companies that I've talked to that are using AppFabric Cache have taken a bunch of old desktops, right? Maxed them on RAM and put them in their data center, and there's their cache. There's their distributed cache. If one of them goes down, no big deal. The other servers or machines in that cluster will take over for the node that was gone, right? So all we really care about is memory. We don't care about disk, because AppFabric Cache doesn't page disk. It just uses memory. We don't care about backup, because there's nothing to back up, because whatever's in the cache, again, if one machine goes down, you can put in another machine, or the other machines will come back up. Okay? The other thing you can do with the AppFabric Cache is enable what's called the local cache. And when I say, a few minutes ago I said performance and scalability, and I said, well, no, wait, I should really say scalability and performance, because distributed caching is really about scalability. But you can get raw performance by enabling the local cache, and essentially then you have both things, right? You have a distributed cache that can help take the load off of your database tier. Then you have a local in-memory cache, and everything that a particular node does with the cache, when you have the local cache enabled, will now have an in-memory version of that data as well. Of course, when you turn on the local cache, then you start having to go back and look at the cache coherency problem, right? Because it is possible then for the cache, the distributed cache, to have one version of the data, and the local cache on one machine to have another version, and the local cache on the third machine to have a different version. It all gets synced up fairly quickly, but there's no guarantees on it will all get synced up within 50 milliseconds, right? It could take 50 milliseconds, or it could take 100 milliseconds, or it could take a few seconds, and in which case you still have the same problem with the CEO getting the wrong copy of the report, right? So the local cache is something that you want to turn on purely for performance reasons, and probably just for those things that we called reference data, right? That's what we typically want to turn it on for. Now, again, that's not a hard and fast rule. Amazon, you would think that maybe they would treat their inventory data as data that they wouldn't want to cache locally on their web tier, but they do, right? And so if I go to buy a book and you go to buy a book, and Amazon says there's one copy, and if I go to one data center and you go to another data center, Amazon's going to let us both buy that book. And then once it realizes and sort of fixes stuff up on the back end, it goes, oops, right? Caching problem. There really is only one copy of that book, and we told both of these people that they could have it. I'm sorry, what's your name? Herman. So Herman is going to get the book. I'm going to email that says, we're sorry. We thought we had that book, but we don't. We'll notify you as soon as the book is back in stock, right? They compensate, right? They say, we're sorry, right? The email says, we're sorry, right? That's okay. Obviously, Amazon, that works for their business model. Facebook, for those of you that are on Facebook, you refresh your Facebook page and you see a post and you're like, oh, I'd like to look at that post. And then you click on the post and it says, there's no post here. And you go back and refresh Facebook again and the post is gone. And you refresh again and the post is back. Anybody ever had that happen? Facebook's like, yeah, we're going to cache things like crazy. Eventually we'll get consistency between our data centers. But, it's just, what your friends or family are doing. It's not, it's not a transaction at your bank, which you would hope that your bank wouldn't do what Amazon would do and say, oh, yes, you really do have the money. Oh, no, wait, you don't have the money. We're sorry, right? Actually, you're the one that's going to have to be sending the emails that says, oops, I'm sorry, right? So it really depends on what you're building, right? How you're going to use the cache. So, again, mostly what I'm giving you is just guidelines, right? There's no hard and fast rules necessarily for how you can use it. Local cache in memory increases performance, gets us back to the cache coherency problem of any in-memory cache. And of course, you can choose just to cache some data locally. You can control, right? What data gets cached locally, what data gets cached in the distributed cache, right? You can choose, okay? So all of the nodes in the cache cluster cooperate together, communicate. So as I said, if one node in the cluster goes down, all the other nodes in the cluster know this and can take over for the node that went down. Now, what happens to the data that's in that node? Well, by default, the data that's in that node goes poof, right? It's gone, right? So if I have, certain piece of data stored in the distributed cache, I don't care what node it's stored on, not my business, just like, in .NET programming, we don't care what memory address a particular object is stored at, right? We let the .NET runtime take care of that. If I put an object in the cache, I don't care what server the cache puts it on. I'm going to rely on the cache to partition the data across all of the nodes in the way that it sees fit. That's where the intellectual property of the AppFabric cache is, right? There's all these algorithms that they built to figure out, okay, the application is putting in this data. Where should we put it? Who's got how much memory on each node? Oh, look, this node has a lot more memory. Let's take this data from that node and move it over there. And let's take that data from that node and move it over here, right? Just like the garbage collector in .NET can move objects around on the heap, right? Distributed cache can move objects around on the nodes. And if we follow the cache-aside pattern, we don't care if node 1 goes down and we lose a bunch of data. If node 1 goes down and we lose a bunch of data that's in the cache, if we're using the cache-aside pattern, that means when our code goes to ask for object A, and if object A was unfortunately on node 1, which is the node that I just magically made go down, right, in my hypothetical scenario, that means we go get the data that would be stored in object A, we put the data back into object A, we put object A back in the cache, and now one of the other nodes in the cache has object A, we're back and we're happy, okay? Now, what if it's more important data than that, right? What if you'd really rather not have that situation happen? You'd rather have, once I put an object in the cache, I'd really like the cache to take better care of it. There is a feature on premise called high availability. All of the features on the feature set on premise is more filled out than the feature set on Azure, right? That's the current state, right? Azure has the advantage of being in the Azure data centers. It has the advantage of you not having to manage the servers. It has the disadvantage of it doesn't have all of the features that the local version has yet, right? And obviously, that's on the roadmap. But one of the features of on-premise is high availability, which means that the cache will store the data in at least 2 nodes, okay? Not at least. In exactly 2 nodes, I should say, in this version. So in this version, it will store it in exactly 2 nodes. And so that means if object A is a really important piece of data like the company's most recent financial report, and you want that to be always in the cache, if node 1 has object A, one of the other nodes is also going to have object A if you're using high availability. That means if object 1 goes down, loses object A, the cache knows this. Node 3 takes over. It becomes the primary node for that data. And the next time you ask for that data from the cache, it just routes you over to that node that now is the primary node for that data. Okay? So in general, the cache is not meant for data that you can't afford to lose, because of course it is a volatile cache, right? It's an in-memory cache. But if you have data that is important, at least important enough that you want to protect it from a single node failure, you can turn on that feature called high availability. Okay? And this is part of the whole communicate, cooperate kind of thing. Right? We have this cluster. It acts as a single entity to us, and it has a bunch of features. And those features are on-premise, including high availability. The general feature is the distributed cache acts like a single cache unit to us. We don't have to know where the objects are. We don't care where the objects are. We just ask the cache for the object. If the object's not in the cache, we're going to go get it. We're going to put it in the cache. And then everybody else after that's going to be happy, right? Because it's going to continue to be garnered from the cache at least until the object expires. Okay, Azure. Again, there's a few features that aren't in Azure. And actually, I have a slide later where we'll go into that. The APIs are identical. So this is nice. The way you program against it is essentially identical. The way you configure your clients against it is essentially identical. The other cool thing about the Azure version is you don't have to, obviously, ever install a server. And if you want to add memory, all you have to do is tell the cache. You just say, hey, could you bump it up from 128 megabytes to 4 gigabytes? And when it does that, it doesn't actually make you lose data. It actually keeps your existing data and just expands the amount of data that you have. Obviously, if you reduce the size, it will start to evict things, right? Because if you say, I want 4 gigabytes, and you fill up the 4 gigabytes, and then you say, no, wait, I want 128 megabytes, it's going to have to get rid of 3+ gigabytes of data, and so it's going to start evicting the data. So there are other cache products out there. The one that, just so you know, the one that Facebook uses is called Memcached. It's an open source one that runs on mostly Linux. There are some other .NET ones. Really, the advantage of AppFabric Cache is the fact that it's built from the ground up with .NET. It comes from Microsoft. The server version is free, right? So it's part of, which I shouldn't say it's free. It's part of Windows Server. So when you pay for Windows Server, you get AppFabric Cache, right? You can't just download it for free and run it anywhere. You have to have Windows Server. To use the high availability feature, just so you know, you have to have Enterprise Edition of Windows Server. Obviously, the version in the cloud is going to cost money. They actually haven't announced the exact pricing yet. And from now until August, I believe, I think it's free. I believe it's until August. So if you want to use the one in the cloud and test it out, they're essentially putting it up there for free for the time being. At some point, obviously, they're going to start charging, and it will be based upon the amount of memory that you use. But in terms of if you already have a local set of Windows servers, you can install the AppFabric Cache on all of them. There's no extra licensing charge. The performance, as you increase the number of servers, is typically pretty linear. So you can just keep adding servers and adding servers and adding more memory and adding more memory. And then, of course, for raw performance, as I'll show you in the demo in a few minutes, you can get some increased performance per request. Okay? Demo. Wrong button, that button. Cool. Okay, so I'm going to do a couple demos. I've got about 40 minutes left. So the 300 level session, that breaks it down just pretty much half and half demo and talking. The other thing is I hope we'll have time for questions at the end. I forgot to put it up on the slide, so let me put it up now. Let me find my favorite editor, visualnotepad.net. You can always email me questions at johnf@mcwtech.com. That's the company I work for. So if you're interested, you can feel free to do that after as well. So what am I going to show you in terms of a demo? Here's an application. It's going out and getting some data from Twitter. As the application says, this is now required by the Technical Speakers Association. Right, they hand us a little note when we get to TechEd and it says, you must do a demo on, and in web services it used to be calculator. Right? We were required by our technical speaker contract to do at least one calculator demo if we were doing web services. Now we're pretty much required to do Twitter. I haven't done Twitter in any of my talks yet this week, so here we go. I'm going out to Twitter and I'm getting tweets. What am I getting tweets about? I'm getting tweets about MS TechEd. I've got a little bit of jQuery in there and a little bit of code that puts the page execution time at the top of the page. So we can just see right away. There's no caching going on. Every time I press F5, it's about the same, right? Anywhere from 200 to 500 to 600 milliseconds per request. And I'm going out to Twitter every time asking for the most recent tweets that have the hashtag of MS TechEd, and then I'm displaying them on the page. Okay? Let's add caching. What I'm going to do is go to my web project, which is using MVC. It doesn't matter. Obviously, you can use this from web forms as well or from a service. I'm going to add a reference, and I'm going to browse and get to the .NET assemblies for AppFabric cache. And let me go over and show you where they are. I'm running a 64-bit version of Windows. So if I go under Windows, I go under System 32. There's a folder called AppFabric. And inside of AppFabric, there are a couple of DLLs. Okay. These are the DLLs I want. Microsoft at application server.caching.client and caching.core. Those are the two main assemblies you'll use for the cloud version as well, but the cloud version has a separate set of DLLs. So there's a couple things to look out for. First of all is if you have one machine and you're trying to use both the cloud version and the local version, that doesn't really work because .NET, whenever you say, I want to use this assembly, no matter where you added the reference from it, is always going to load the version in the GAC. So your two options are have two different machines for developing against AppFabric cache or locally and in the cloud, or try to take them out of the GAC, which generally doesn't work very well. So I'd stick with a virtual machine or something like that for the other scenario. So let's go find those assemblies. C Windows, right? System 32. Didn't it say, what's the directory? AppFabric. Huh. I don't see an AppFabric folder there. Odd. Well, maybe I can just type it in. C:\Windows \system 32 /AppFabric. Didn't seem to like that. Maybe I typed it in wrong. Let's copy it. And as you might guess, no, copying doesn't work either. The reason is that Visual Studio is a 32-bit process. When you open the file open dialog, which this is, inside of a 32-bit process, it doesn't see all the 64-bit stuff inside of Windows. This doesn't actually really exist, right? That folder doesn't really exist. Explorer is just making it look like it exists, right? It's actually down inside of some other folder. So how do you deal with that? Well, once you've added the reference once, it goes up on your recent, so it's not that bad. Otherwise, you need to do this, $winder/sysnative. Once you do $winder/sysnative, notice that it lets me go to the AppFabric folder, and then I can add those two references. No, I think because I had AppFabric in my directory when I hit enter, I think it, I don't know. I actually thought that was a little weird. I was like, why did I go right to AppFabric, right? Because I really should have gone, let's try this again, add reference. Let's go up here, go to C. So windir, this is a fun thing to have to remember, /sysnative. Okay, so that brings me basically into what, just like what Explorer shows me System32 looks like. It's a combination of the 32-bit and the 64-bit stuff. And then I can go to AppFabric. And then those are the two assemblies, okay? Application.caching.client, application.caching.core. Okay. How am I going to program against the AppFabric cache? What I'm going to do is I'm going to start out creating something called the data cache factory. If you've ever looked at the Gang of Four book or any other book that describes the factory pattern, this is a classic factory pattern. I'm going to say I want a static variable that's data cache factory. I'm going to call it factory. I'm going to say new data cache factory. Okay? I'm making it static because the data cache factory is expensive and I'd want to keep it around for longer than per request. So the idea is I don't want to say new data cache factory on every request. If I do, and this is all docked in their docs, performance is going to suffer. So you want to create a static instance of this. You can put it at application scope, whatever scope makes sense for your application. For purposes of this demo, I just want to keep it right here so that we can see that it's there. And what am I going to do here? What I'm going to do here now is, this is my code. I've got a little bit of code that I call the Twitter data source that I'm going to get data from Twitter, right? That's not really the important part. The important part is I'm going to get data, and going to get that data is expensive. And so those are the two sort of basic classifications of data that you want to cache. One is the classification I talked about before, which is stuff that doesn't change very often that you can cache in your caching layer and thus keep the database from having to return that sort of routine reference data, and you can free up your SQL Server, your database, for other things. Another one is, what if I have something to go get that's really expensive, like going out on the internet and asking for data from some Web 2.0 web service like Twitter? That would be another example of stuff that you'd want to cache. So this is what I'm going to do. I'm going to say I would like the cache, please. I'm going to go to the data cache factory and say I would like to get the cache. The cache I would like to get is called the Twitter cache. I've already created the Twitter cache locally. I'm running, just to be clear, I'm doing this locally, right? So everything I do on my machine, I'm going to show you, is against the local version of AppFabric. I'm going to show you an application that's running in Azure right now, where I'm using the AppFabric cache as well, similar application, but that's, again, running inside of Azure. So I'm going to my local cluster, and I'm saying I'd like to get a cache. And the way that you administer your local cluster of AppFabric caches is through PowerShell. So there's no UI in this version. The way that you administer the cache is by using PowerShell. If I say in PowerShell get cache cluster, let's do start cache cluster. Start cache cluster. Okay. Notice that I get an error that says, hey, your cache cluster is already up. Woohoo, you have one node, right? I'm running it locally. For development purposes, you can run it locally on Windows 7 or Windows Server 2008. What else can I find out? I can find out about, what are the caches that are available, okay? And so I have two caches. One's called Twitter cache, which I pre-created. One's called default, which is the default cache. When you install AppFabric cache, you get a default cache, and that you could just use. I happen to want to partition things, so I'm going to say I want my Twitter data to be inside of my Twitter cache. So the question is there any performance from partitioning? And the answer is, the answer is complicated. Let me give you the basic answer, since, if you want to follow up later, I can give you the more complicated answer. The basic answer is no. You'd create multiple named caches based upon requirements. So for example, the high availability I talked about is a feature, but I wouldn't want to turn it on for my Twitter data, because I don't really want two copies of that around. One's good enough. If my copy of my Twitter data goes away, I'll just go get it again, not a big deal. And that feature is on a named cache basis. So I typically break up my caches into multiple caches when I want different features. Okay? It's a little bit different in Azure, as we'll talk about, but that's basically locally no. Okay, so I'm getting the cache, and then I'm going to say, I would like to see if this object is in the cache. So first I have to decide what the key of this object is going to be, right? So what I'm going to say is I'm going to say the key of my object is going to be Twitter data, plus query, right? Because I'm executing multiple queries potentially against Twitter, I don't want to overwrite one query with another query, right? So I want to have a unique key per query. So that should do it. And then I'm going to say model equals cache bracket key as tweets, which is my collection object for tweets, right? So that's my first part of my cache aside pattern, right? I'm going to look and see, is this data in the cache? Give it the key. If it is, I'm going to go on happily along my way and use the data by passing it to my view. If I was doing web forms, I'd be data binding it to some control, right? Same thing. But if model is still null at this point, that means what? Not in the cache. So I'm going to go get it, and then I'm going to put it in the cache. I'm going to call cache.add. Actually, I'm going to call cache.put. There are two APIs for adding things to the cache. Cache.add, if the item is already in the cache, will throw an exception. Cache.put will just override the object if it's already in the cache. So I'm going to do cache.put in this case. I'm going to put in the key. I'm going to put in the object. And then I can add other parameters. Notice that datacache.put has 16 overloads. So there's sort of a very sophisticated API here for doing all sorts of interesting things. Just a couple of examples. One is, what if that data already is in the cache and I don't want to put it in unless it's different? The override that came up on my IntelliSense allowed me to pass in this thing called a data cache item version. So this is the feature of the cache that's referred to as optimistic concurrency. That is, if I pass in a version and a newer version than the one I'm passing already exists, then it throws an exception, right? So I'm basically saying, hey, I don't want to add something to the cache if somebody else has already added something newer than the one I had before, whatever that was, okay? I'm not going to go into all 16 overloads. You can do that at your leisure. I'm going to say I want a new time span because I want the data to stay in the cache for only a minute, right? And then after a minute, I want it to go away, okay? So this is the programming bit, right? Let me walk over it just one more time. I create a data cache factory. I go to the data cache factory and I say, I would like to have a particular cache. I could also say factory.getDefaultCache, which would give me the default cache. I'm going to go see if the cache has my data, asking it by key. Key value pairs, right? That's what's stored in the cache, just like any sort of property bag. If that key value is there, that means it was in the cache and I'm going to use it. If it wasn't there, it wasn't in the cache, I'm going to go get it, and then I'm going to put it in the cache, and then I'm going to use it, and every subsequent request, right, is going to get the version that's in the cache until the object is removed from the cache. The default expiration of objects in the cache is 10 minutes. You can change that. I've changed it for this particular object by saying, I'd like this to expire in a minute, okay? There's one other thing I'm going to do, not related to the cache, but related to my little timer that I have. What I have is essentially a http://context.items object, which is a per request object. And what I'm going to do is, if the item isn't in the cache, I'm going to say, Snagit. That's my Snagit tool, sorry. Hey, I really wanted a screenshot of that. Let's see if my keyboard is, okay. Data, I don't want to yell at anybody. Data was not in the cache, right? And then, oops, that's not going to compile. Else, this equals data was in the cache. So this is just going to allow me to, for demo purposes, print out, whether we know the data was found in the cache or not found in the cache, and it's going to continue to print out the amount of time it took, okay? Now, I still have to do one other thing, okay? The other thing I have to do is I have to configure this object. I have to tell the data cache factory what cache cluster to use, okay? It doesn't just figure it out magically. It does it by configuration. I can either put that configuration in my web.config, or I can put that configuration into code, okay? I can choose which one. I'm going to put it into the web.config for simplicity. So the first thing I need inside of my web.config is I need a config sections element, because there's a special configuration section handler that the cache has that I have to install so that my application will understand how to parse its config. I get tired of typing it in, so I created a set of XML snippets for this. So there is my config section. It's really pretty easy. You just give it a name and point it to the data cache client section, okay? And then I'm going to add a client section, which, as you can imagine, I also have a snippet for, okay? So here's my data cache client, right? I'm specifying the hosts. In the case of the on-premise version, this is where there is a little bit of difference. The configuration is the same, but the way you go about it is slightly different. The configuration name, host is all the same. For the cloud version, you only have to configure one name, right? One DNS entry. And then the cloud version figures out where all the cache clusters are. In the on-premise version, you need to put at least one entry here, so at least one of the nodes in your cache cluster. But of course, what if that node goes down? Then how is your application to connect to the cluster? So in this version, what you have to do is you actually have to put in, or you're recommended, it's recommended, not have to, it's recommended that you put in as many entries as hosts that you have. So let's say that I did have, 3 hosts, right? I'd put in 1, 2, 3, 1, 2. And then if the localhost node was down when my client tried to connect, it would connect to localhost 1. If localhost 1 was down, it would connect to localhost 2. Once it's connected to the cluster, you can think about your client as being part of the cluster, part of that cooperative effort to know where data is. In fact, every node knows where all the data is, and if data gets moved, all the nodes are updated about where data is. So even if you have 10 nodes, if I connect to node 1, if the data I want is on node 10, my client goes right to node 10 to get that data. It doesn't have to hop through the node that I connected to, right? That's an important point. Okay, but because I don't have more than one host, this obviously is not going to work. So let's comment that out. Okay, I could put this in my code too. Again, if you want it in your code, if you want it in your configuration file, same thing. Okay, so let me just double check I've got everything here. Yes, exactly. So that's a great, the question is, what happens if I add another host or 10 other hosts? Do I have to go update all my web.configs? And the answer is no. You don't have to go update them immediately. You probably want to update them at some reasonable point in the future when it's convenient. You would only have to update it if none of the hosts that were in the web config still existed. So let's say I had host 0, 1, 2. I install host 4, 5, and 6. I don't need to go back and change my web.config. But if hosts 0, 1, and 2 die, right, a horrible death, burn, fire, right, go away, then I have to go change my web.config, because obviously the client then won't know. You don't actually even have to change it right away, but you want to change it as fast as possible. Because of course, once the client has been part of the cluster, right, it still knows where everything is. That's one of the reasons the cache, the data cache factory, is that it knows all that information. Question in the back? Yeah, so the question is, how can I fix this? Because it's a little bit of it's kind of a weird thing. The only way to really fix it, NLB or anything like that won't really work. The only way to really fix it is some people have written like a web service that keeps a list of their hosts, and then in code, rather than in configuration file, gets the list of hosts and dynamically configures the cache factory rather than doing it with a config file. But there isn't any other really good solution today, unfortunately. There was a question over here. Still a question? No? Okay, one other question.
So what you're explaining is all the nodes know where the data is, but not, they don't know, but they don't have the actual data unless it's high availability data, right?
Correct. All the nodes know where all the data is at all time within reasonable, time limits, right? Of course, things change. So once things change, there's communication. Unless, yes, you have high availability, in which case 2 nodes would have that data.
But do they have continuous replication? So node A goes down with the data, then node B, everything gets redirected to node B. But then if you bring something else, does it get replicated to node C?
Well, your question, you first have to answer the question, is high availability turned on? So there's 2 different answers, right? If I have 3 nodes and high availability is turned on, and the primary node goes down, then the secondary node that was also holding that data becomes primary, and the 3rd node becomes secondary. Okay? If you're not using high availability, if a node goes down, all of the data in that node disappears from the cluster. Then the client is responsible for saying, oh, look, that data is not in the cluster anymore. Let me put it in the cluster.
If it is high availability, then it's redirected, but then does node C gets the copy?
Yes. Then another node becomes, the secondary node is promoted to primary, and another node is promoted to secondary, assuming that you have another node, which means if you're using high availability, you want to have at least 3 servers in your cluster at all time. Otherwise, you don't have high availability. Let's see if this works. Control F5. That's my cloud version. We'll get to that in a minute. Okay, so the first time I hit the page, it says page execution time was pretty high. Of course, there was a lot of compilation and stuff that went into that. And the data was not in the cache. Now, data is in the cache. Data's in the cache. It's going a little bit faster, right? I don't even have local cache turned on, right? If I turn on local cache, I probably won't see much difference, right? Now, again, my scenario is not necessarily the performance metric you want to take away from this session, because my web server is running on the same server as my cache cluster, which means that network latency is pretty low, right? It's pretty tight connection there. In fact, you want to be very careful about how you measure performance when you're looking at using the cache. For example, I won't show it to you, but I have done tests on my local machine where I've had a page that goes to SQL Server every time to get a 10,000 row set of records on my local machine versus putting it in the cache on my local machine and having my web server get it every time from the cache after the first time. SQL Server is actually faster. Right? Why is SQL Server faster? SQL Server is faster because SQL Server is running on my local machine. It's using the shared memory provider. SQL Server caches stuff too. So on my local machine, in that particular scenario, SQL Server is faster than the AppFabric cache. AppFabric cache, I actually have to open a network connection. Even though it's on my local machine, it's still a socket. It's using, under the covers, WCF's NetTCP binding. So it's actually doing a call on my local machine. It's slower than going to my SQL Express instance when I put it under load. Now, if I turn on local cache, once I turn on local cache, then AppFabric cache is, again, faster than SQL Server on my local machine. Again, this is not a set of metrics that you want to go back and say, this is what's true about AppFabric cache. That's a particular experiment that I did. But you have to remember is that when you're going to the cache, you're going out through a network boundary, right? You're distributed. You're going across the network. And so that's going to have some cost associated with it. Now, if you do the test against the network SQL Server in your local environment, and SQL Server is still faster on a particular page request than AppFabric cache, does that mean you don't want to use AppFabric cache? And the answer is no. The point of AppFabric cache is not to make individual page requests faster. It's to take the load off of your database so that it's not doing that. So the only really fair test is to test it when your database is under heavy load, right? What happens when my database is under heavy load and somebody starts hammering this page? What happens then, right? That's the real thing that we're testing here, or we should be testing. Okay.
How come your second hit was, 0.8 of a second, and it went way down?
Oh, why was the second hit? That's just, ASP.NET warming up, that kind of stuff, I mean, once ASP.NET gets everything sort of in its pipeline, right, obviously it's caching objects and compiling and stuff like that. So, yeah, that's why. Okay, so data is in the cache, right? So, nice and fast, okay? Now, what about this same application inside of Windows Azure? Let me go ahead and take away this query string. If I pass it a different query string, by the way, we'll see that data is not cached. So I'm going to say query equals Flanders, which you typically get a bunch of stuff either about Ned or the part of Belgium that is referred to as Flanders. But notice that's how long it took to go out to Twitter, gather all this data, and execute the page. And now that particular piece of data is going to be stored in the cache. And again, we're back down to 2-3 milliseconds, right? Let's go to Azure, right? So now I'm getting, again, tweets about MS Tech Ed. That's how long it took to execute on Azure. Now I'm caching, right? And this is measuring execution time on the server, just to be clear, right? I have a timer that starts when the request begins and ends when the request ends, and then that number is getting pushed into my page and dropped up here by some JavaScript. So you can see, again, pretty good, right? Pretty good in terms of what happens when I have to go out to Twitter to get data. What happens when I have to go to some data source that's far away from my server, and I have to go out there constantly? Well, that's going to be, not going to be highly scalable. But what if I can put it in a distributed cache that's part of my cluster inside of the same data center, right? That's the one thing you want to make sure about when you're doing Azure, right? Is when you go to allocate the cache, which I'll show you how you do it over here. I go to the management portal. I go down here to Service Bus Access Control and Caching, which is a node down here inside of the Azure portal, which I'm already signed into. And then I could say new namespace, right? The namespace is essentially the name of the cluster that you want to create. So I can create, say new cluster. I can specify the county and region. So, if my Azure app is in North Central, I want my cache cluster to be in North Central. If I've created a region, I could do that. I specify what subscription, which is no good. And then I specify, what do I want for cache size, right? 128 megabytes up to 4 gigabytes. And again, I can change that dynamically without having to recreate the whole cluster, right? I can say, I want to move from 2 gigabytes to 4 gigabytes, right? And it just says, oh, you got 4 gigabytes of space now, okay? So this page right here, right, is using, just to be clear, is using Azure. It's the same app, basically, deployed to Azure. And it's running essentially the same code. And its back end is the distributed cache, the Azure AppFabric cache. Sorry, the AppFabric cache is living in Azure, right? My other example was the AppFabric cache running locally. Okay? Make sense? Programming model is very easy. Again, the programming model is in many ways very similar to the HTTP cache, right? I can use the indexers to say add a key or get a key. I've got the add method, I've got the put method, there's a get method, and there's a whole bunch of other features, right? There's lots of other features. There's high availability. On the local cache, there is notifications, so I can get notified when items are removed from the cache. I have a little bit more control over numbers of caches locally, because I can create named caches locally. On Azure, there's one cache. It's the default cache for right now. So there are some feature differences. It's pretty easy to decide which one you want to use. If you're building a Windows Azure application, pretty much a no-brainer to use the Azure cache because it lives in the same data center as your application. If you're on-premise, it's pretty easy. You want your cache to live in the same data center as your application, and so then you want to use the on-premise version. Going from on-premise application to Azure Cache is not really a recommended architecture. The only reason that you might do that is, of course, if you have an Azure application and it's caching data, but you also want to cache data from a local application as well, of course, it is open. You can connect to the cache from your local environments. And you could, for example, one of the common things that people want to do with the cache is prime it, right? So when my application starts up, I want to prime the cache with all the data that I think I need or know that I need. Well, you could have that run in Azure as a worker role, or you could have that run locally and have a service that does that. And of course, it can connect to the Azure cache through its API. The configuration is exactly the same. You just wouldn't want to rely on it for a local application for reads, because that would be, the network latency of that is pretty big, right? Okay, so another example. Let me show you another example. I have another example that is an application that's sort of, more finished, complete, called Blue Yonder. It's a mythical airline. So an example of where Blue Yonder might use caching is, of course, there's a lot of data that this application, this web application needs that doesn't change very often. For example, the list of airports, right? What are the list of airports in the world? The list of airports in the world changes fairly infrequently, right? Airports are added, airports are removed, but it doesn't change very often. So in this application, I want to cache the list of airports, because of course that'll make things faster. For example, let me open this in a new tab. When I go to book a flight, one of the things that I'm going to have to do is pick, where do I want to fly from? And I can put in an airport code, and I have a little autocomplete happening there with a little jQuery and a little web service. Well, of course, if that has to go back to the database every time for that data, that little UI widget is going to be fairly unperformant, fairly slow. And again, I want my database to be there to be ready to take money, not to serve up lists of airports that don't change very often. So I'm caching that. And what I'm doing in this particular example is very similar to my first example, except I've wrapped the cache behind an internal sort of service, an interface that I've created. And so what that lets me do very easily is, without having to change any of my code, I'm just going to go ahead and remove my reference. I have a reference to an implementation of my cache interface called HTTP cache, which is using the ASP.NET cache. I'm going to remove that. And I'm going to add a reference to my AppFabric cache implementation. Now, of course, that does take a recompile because I'm changing my references. But if I go back over here after the bill succeeded, oh, yeah. And of course, it would be helpful if I actually put config. That's what happens if you don't put the configuration for your cache in the configuration file. I took that out. The other thing that I've done in this particular example is I've added the local cache. So I've said local cache enabled equals to true. So that means not only am I doing distributed cache as I was in the early example, now I've turned on the local cache. So let's go ahead and save that. Go back and refresh this page. What did I do? Localhost. Config sections. Data cache clients. Let's do a build. Cache referred to. Oh, cache referred to does not exist. I was going to show you the guys this. Aha, see? My brain, of course, is 90% full as well. But what am I doing? I'm doing a particular cache in this case. The cache I'm trying to ask for is called reference data cache. How do I create a cache locally? I just say new cache. I'm going to say new cache, reference data cache. There we go. If I had actually looked at the error message, I probably would have not gone back twice. Notice that I'm getting another error message. This is the other thing that I was going to show you. Didn't intend for the error, but it's OK. The other thing that comes with AppFabric Cache is a session state provider. So if you want to have a session state provider that gives you an out-of-process session state store in a web farm environment, this is the part that can allow you to do activity data, which is what typically we call session data, without having to do sticky sessions. So new cache, blue under session. Cool? All right. Third time, gotta work, right? There we go. So the data is cached, and I'm caching it using the AppFabric cache implementation. And you can see that, again, as in the other case, pretty much the same. If I want to, I can actually go over here and say get cache statistics. And I can say reference data cache. Right? And this will show me how many objects are in the cache and the count and the hit count and everything like that, which is good. And if I go, say, get cache statistics, blue yonder session, I should get 0. That's what I would expect. How can I get something into the session? Well, again, in this application, when a user logs in, I'll log in as the ubiquitous Ken Sanchez from AdventureWorks. Oh, come on. Password has not changed. Oh, man. Actually, I don't think I have to sign in, so let's pretend that I'm signed in. I want to fly from LA to JFK, right? I'm departing tomorrow, I'm getting back then, and I go to search. And then as the user gets sent through the different pages and says, oh, this is the flight I want, this is the flight I want. Of course, that's the kind of data that you might store in session. There's my, my place where I can put in my credit card and everything. And if I go back over here, there we go, right? We can see that there's now data in the session, right? My session data is automatically stored in the distributed cache. What's the advantage of that? It's stored out of process from my web server. So if my web server goes down or if my user gets routed to another node in my web farm, session data will be exactly the same. Yes, if the node that holds my session data goes away, that session data is lost just like any other data in the cache. If I've got a local cache cluster, I could turn on high availability. In the distributed cache, no viability in this particular version. So whether you want to put certain data in session and out of process like that is a thing you have to look at the particular piece of data and figure out how important is that data to me. Yes, sir.
When you use the PowerShell to create a partition and you put it out on the distributed cache, you bring all those servers down. Do you have to re-add that now?
So the question is, if I add a cache and then all the servers go down for maintenance or something, when I bring it back up, do I have to recreate everything? And the answer is no. That configuration is stored either in a config file locally or in a database, SQL Server. So I get to choose when I install AppFabric Cache on-premise, do I want to store my config in SQL Server or on a file? Either way, it's stored in that place. So when the cluster comes back up or a new node joins the cluster, it gets the configuration from the configuration store, and everything's remembered. So the answer is no, you don't have to recreate that.
All right, just one more question.
Yeah, sure.
As far as like performance, how does the Microsoft implementation of this stand up for like MegaSpace or Java?
I've not seen, the question is about performance. There is, if you do a search, and if you can't find it, send me an email and I'll send you the link. There is a white paper on performance where they did a performance difference between some of the .NET versions. I don't believe they've done any compete against any of the Java implementations yet. On Windows, it stands up very, very well to memcached. Also, on the local version, it has more features than memcached. For example, memcached doesn't have high availability. I don't know anything about the Gigaspace. I can put you in touch with the people at Microsoft who do the compete stuff, and they might be able to give you more information. So if you send me an email, I'm happy to do that. I don't do compete, so I don't. I've looked at memcached, and I've looked at a couple other ones just to see how it works, but mostly I've dealt with the cache with that AppFabric. Yeah, that'd be great. One other question, and then I'm going to finish up. Can you create those caches programmatically? And the answer is, you can create them programmatically if you use the PowerShell commandlets programmatically. So there isn't a full API for all of the administration of AppFabric Cache. There's the APIs for programming, PowerShell is for administrating, but you can call PowerShell commandlets from .NET code. So yes, you can write the code that does that, absolutely. Just quickly, again, some features are not in the cloud yet, so no notifications, no high availability. Tags and regions, we didn't really get into that, but that's sort of a further classification of data in your cache cluster. Expiration, you can change that on a cache-by-cache basis locally. By default, in the cache cluster in Azure, it's 10 minutes, but you can change it on a per-object basis, which I was doing. And eviction, there's no way to change the eviction settings. On the local cache, you can say, don't ever evict any objects from this cache ever if you want to, right? So the big, I mean, you don't have to remember all these, but the big thing to remember is, you know, the decision between using Azure Cache and local cache really shouldn't be about these features. It should be about where is your application living. If your application is living inside of Azure, you want to use the Azure Cache. If your application is living locally, you want to use the local cache. You don't want to, so to speak, from Ghostbusters, right, cross the streams, right? There's no reason to do that in a production environment. As they move forward, that might change, but that's the recommendation right now, okay? So thank you guys for coming. Enjoy your last couple of sessions. And please do your evaluations. Evaluations are really important to us. Remember that the higher number is better, right? Higher is better. And if any of you other have questions, please feel free to come up. I'm going to be packing up and moving out because there's probably another session. But thank you very much.